Kia ora tātou, welcome to this video where we will look at atoms and electron configurations. So a good place to start with this is the periodic table. So this is the periodic table that you will get in your exam as your resource booklet. So we can see here we've got atom symbols, but we don't have any atom names. So H, He, Li, Be. So a really good thing to do is if you're able to memorize up until number 20, what these symbols stand for. So the hard ones would be like Na is sodium, K is potassium, those sorts of things. So see if you can get that far with the periodic table, memorizing the symbols. And then the other things we need to know about this periodic table is what the numbers mean. So up the top left hand side, these are called the atomic numbers. And we will get to those in a second, what they actually do. And then you'll see there's more numbers here that are on the top of the column. So you've got them all along here as well. And these are the group numbers. So let's look at what these mean. So the atomic numbers, that means the number of protons that an atom or an element has in its nucleus. And so we'll look at the atomic structure in a second and show what that means, number of protons. And this group number, that's just showing, you can see it's just each column has its own number. So this column is column number 1 here, then column number 2, column number 3, and that's useful, and we'll see why that's useful in a second. But those groups is just numbering the columns. So group is the name for columns on the periodic table, and that's it. If we were to go across from the left to the right, those would be the periods, so the periodic table. Okay, so let's look at what these mean. So we'll take fluorine and draw the atomic structure of fluorine to begin with. So I'll get myself some space. So fluorine has the atomic number of 9, and so that means that fluorine has got 9 protons. So I'm just going to go protons times 9 in its nucleus. So in the nucleus of an atom, we've got protons, which have a positive charge, neutrons, which are free of charge, and then electrons, which are around the outside of the nucleus. So in this atom, there's going to be some neutrons as well inside the nucleus, but we don't actually need to worry about those. We just need, they're going to be approximately the same amount of neutrons as protons. Okay, and then around the outside, we're going to have our electrons. So when an element is in its atomic form, it's going to have the same number of electrons as it does protons. So for this fluorine atom, we're going to have 9 electrons. So around this nucleus, we're going to have 1 electron there and another electron there. What you'll see I've drawn here is called a shell, or an electron shell. So the electrons orbit around the nucleus of an atom. So the way that it works is that we can fit 2 into the first shell, and then we can fit a maximum of 8 into the second shell. It's a terrible circle. Here we go. So now we've used up 2 of our 9, because we've got 9 electrons in this case. So we're going to use up 7 more around this next shell. So 1, 2, 3, 4, 5, 6, 7. So we've got 7 electrons in the outer shell of this fluorine atom. So this is the outer, or you might hear valence shell. Okay, so those 7 electrons in the outer shell are important. It's important that that's just one off being a full shell, and we'll look at why that's important when we look at ion configurations. However, for the moment, this is all we need to know. So 2 electrons can fit into the first shell, and a maximum of 8 electrons fit into the second shell. So sometimes we want to show the electron configuration of an atom, and we don't want to draw out the whole atom every time. So what we can do instead is show that fluorine has got 2 electrons in its first shell by doing it, putting the number 2, and then a comma indicates that we're now going to the next shell, and we're going to put a 7. So that means that we've got 7 electrons in the next shell. Let's look at another example. So we've taken fluorine there. Let's go to chlorine, which is in the next period along. So chlorine has the atomic number of 17. We can see 17 there. So this is going to have 17 protons in its nucleus. And then so it's going to have 17 electrons when it's an atom. So we can still only fit 2 in the first shell, so 2 are done there. So we've started off with 17 and now we're down to 15 left. So we need to put 8 into the next shell. 1, 2, 3, 4, 5, 6, 7, 8. And so those are all used up. So we now have 15 minus 8 is going to be 7. We've got 7 electrons left. And so that means that we've got 7 electrons. 1, 2, 3, 4, 5, 6. 7 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7. And so we would draw this. The electron configuration of this would be 2 to show that there's 2 electrons in the first shell, 8 to show there's 8 electrons in the second shell, and then a 7 to show that there's 7 electrons in the valence shell. So what you'll notice is that this has 7 electrons in its valence shell, or its outer shell, and fluorine has got 7 electrons in its outer shell, and these are both, fluorine and chlorine, are both in group 17. So what we can do actually is look at these group numbers and take the second number of the group, so 5, 6, 7, or 4 or 3, and then we can also take 1 and 2. The ones down here we don't need to worry about, so we're just taking these group numbers along the top. So these numbers actually tell us the number of electrons that are in the outer shell. So if we did the electron configuration of lithium or sodium or potassium, we would see that there's 1 electron in the outer shell. If we did oxygen or sulfur, we would see that there's 6 electrons in the outer shell. Or even helium, neon or argon, we would see there's 8 electrons in the outer shell. I'll leave you to give that a go, but that's how we do electron configurations for atoms, and that's how we relate it back to the periodic table. The only one other thing I would say is that the periods, so as we go down a period, so from lithium to sodium, the difference between lithium and sodium is that this is going to have a total shell more. So if we see the difference between fluorine and chlorine, which are in different periods, fluorine has got 2 shells, so it's in period 2, 1 up the top, then 2, and so how many shells would chlorine have? Well, it's in the 3rd period, so it's going to have 3 shells. And let's have a look at what we've drawn. Yeah, we've got 1, 2, 3 shells. So that's atom configurations and electron configurations of atoms. In the next video, we will look at ion electron configurations. Thanks for watching. See you then.